Okay, for this practice, we're going to need again a battery 9 volts with its clip to power the circuit. We're going to use the breadboard once again to make the connections. We'll require a couple jumpers, male, so we can make the connections easier. Resistors, we're going to need one resistor of 1K, which in this case is brown, black, red. And since we need 50K resistors and we don't have that, we're going to use 2 of 100K to connect them in parallel and get the 50K ohms that we need. In this case, this one is yellow, purple, and brown. We're going to need an LED that will show us if the circuit is working or not. We're going to need an LDR, which is in charge of getting the amount of light of the environment, and we're going to need a transistor. In this case, this is a 2N2222. Remember, from left to right is the leads are emitter, base, and collector. Okay, here in the schematics, we can find the battery here on the right. We have a couple of resistors here. This is a parallel circuit. One resistor here is 1K ohms resistor, and this one is a 50K ohms resistor. Remember that in real life we don't have one resistor of 50K. That means that we're going to plug in parallel 2 resistors of 100K, and that will make half of them. You will see it when I show you how it works. Then we have here the LDR, which is the component that will detect the amount of light. Here we have the LED. And finally, here we have the transistor. As you can see, the transistor, here is the pinout of the transistor with an image of it, and you can see it has 3 different leads, number 1, 2, 3, and here in the schematics, emitter, base, and collector. So things you have to keep in mind when you plug the transistor is how to plug these 3 leads properly so they will fit with the schematic. Here I'm going to draw on the circuit the flow of electrons in red. So basically electrons will go out here. Everything depends on this transistor. One more time, the transistor is like a door. That means that if there is some current here on the base, that will open the door. The door to do what? To make the electrons flow from this point until this other point to touch the LED. So what is going to happen here? This thing will change depending on the amount of light. If there is a lot of light, there will be a lot of resistance. And if there is a lot of resistance, there will be no current here. So the door will be closed. But if there is no light at all, there will be no resistance here. And that will let these electrons that will also flow here to reach this point and follow the cable here. Once the base is open, these electrons that are here will be able to flow to the LED, touch this resistor so the LED will not get burned, and finally reach the end of the circuit. So at the end, if this door is closed, that means we have a lot of light here because there is a lot of resistance, so the electrons cannot flow. The LED will be off always. But if we open this door, that means if this is covered, there is no light at all, the electrons can flow and turn on the LED. Basically, there are 2 states in here. Either the LED is on or is off, depending on the amount of light. But you can control points in the middle by controlling the amount of light here, because as you know, this is a door and it can be completely open or a little bit open or a little bit closed. So that can control how many electrons will flow here, and following that order, the LED will be either a little bit on or completely on. Everything depends on this door, if the door is open or closed. Here I have the circuit. There is a look so you can compare it to the schematics. As I explained here, we have 2 resistors in parallel. That means they are plugged exactly in the same hole of the breadboard. They are 100K resistors, but since they are in parallel, that resistance is divided by 2, so that means they are 50 k ohm resistors. Here we have the complete circuit, having in mind the connections of the transistor, the base, emitter, and collector. And if I plug the battery and I basically cover this, you can see how the LED will go on, depending on the amount of light that is in the environment.